So last but not least, in our exponential functions section, we need to talk about a very special number, which is the number e. So of course, e is a letter, but for us it's going to be a variable, and it's a variable for this particular number that works very well as a base on our exponential functions. It has some special properties, most of which will show up kind of later in calculus. But nevertheless, we want to make sure we're sort of familiar with it and, just sort of know what to expect. So e is an irrational number. It's around 2.718. Is irrational. So meaning it's a non-repeating sort of infinite decimal. So much like pi, right? That another sort of special number that we have a special symbol for. E is a similar kind of thing. And probably we've used the letter e because it's our special exponential base. So right between 2 and 3, if we did a graph of it, we would kind of use that kind of roughly for our scaling. This means our kind of standard exponential function is going to become, so f of x equals e raised to the x. It has a lot of our sort of normal properties, right? If you raise it to the 0, you're going to get 1. If you raise it to the 1, well, you're going to get e to the 1, which is e itself, right? 2.7-ish. If you raise it to the negative 1, you'll get 1 over 2.7-ish, right? You get something a little less than 1/2, and so on and so forth, right? 2e squared, going to be somewhere between 4 and 9. The important thing here, right, is not so much that we're sort of identifying all of these points as precisely as possible, just that we sort of get the general flow, right? If we did just another quick kind of sketch, kind of start to see a little bit what we're sort of doing typically here, right? 1, 2, 2, 0, 1, 2, 3. So as always, we have our sort of 0, 1 here. When the base is 1, right, we're sort of at e, 2.7-ish, somewhere up there, and we're going sort of down and to the right. Down and to the left, and up and to the right. So this is going to be for us, right, f of x equals e to the x. If we want, we can do a couple sketches of graphs, including our shifts, just as a quick example and review and sort of tying it all together. So with shifts, right, maybe we would do g of x equals e to the negative x plus 2, something like that. What is that going to do? Let's see how we can shake this up, right? So there's our regular e to the x above it. So e to the negative x is going to be reflect over which axis, right? So that's the left-right reflection, so that reflects over the y-axis. And then we're also going to move right plus 2. We're going to go up by 2. So that's going to flip us sort of left to right, and it's going to shift everything up 2 units. So if I drew a sketch, let's go kind of 1, 2, 3, 4. What's going to happen for us here, right, is everything shifts up by 2. So now our new asymptote is at 2. I've still got, in theory, what would have been 0, 1 is now 0, 3. We're not moving left or right. And then if we're flipping sort of left to right over the y-axis, so that means I'm sort of dropping to the right, and I'm rising to the left. So that would be for us e to the negative x with a plus 2 on the end. That's the basics of it, right? We could do a little left-right action as well if we wanted to. E to the x, right? So let's say example h is, let's just do e to the x. Let's do, I don't know, plus 3, something like that. Pretty fast. All that's going to do is that's just going to shift us 3 to the left. We're not going up and down. We're not doing any reflections here. Try to leave myself a little bit more space here on the left-hand side. 1, 2, 3, 4. And so our new coordinates, right, our new points, instead of 0, 1, we're shifting everything 1, 2, 3 to the left, 1, 2, 3. So we're at sort of negative 3, 1, flattening out to the left, rising up to the right. So e raised to the x, oops, and then I'm sorry, x plus 3, right, up in the corner. So e to the x is what we call the natural base. E is the natural base, that base number. It's just a number, 2.7-ish, 2.718, yada, 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 more digits. Goes on forever. Can't say them all. But these are some of our graphs, right? The standard graph is here, and then a couple shifts and reflections. There we go.